Okay, so we're just gonna make a start now. So it's our Wednesday morning session remotely. And what I wanted to do this week was to go through the male reproductive system from last week and this week's topic, the female reproductive system. As I discussed with some of you in the class, I got a sense that few of you were a little nervous about the anatomy portion and possibly about the quiz. So what I have done for this session. Hi, thank you for joining me. I was just getting started, so you're not missing anything. So what I was saying for the record that in the class I received a question. There were a few questions about the anatomy and the quiz portion. So that was the plan for today. So really, in terms of, we reviewed in the class the female reproductive system, and there wasn't too much of a new stuff. We discussed the different parts. So just in the interest of time, unless there's any questions about it, I'm just gonna keep going on and move on to the quiz and move on to the anatomy part. So, and let me just jump here. So for the male quiz, I think the questions get pulled from a larger pool, and then you get asked 10 of those. But really, in general, the types of questions and the structures that we are asking are very similar. So I'm just going to take the pointer here. And so, for example, on this first question that came from the pool that I pulled, we would see our friend seminal vesicle, the first gland to actually contribute to the secretions. Remember, that was fructose-rich nutrients for the sperm. The second question from the pool that I pulled was a little bit more laborsome, because you would be labeling from the options that you are given, dragging them to the correct structures. But really the best way to tackle this is to identify the things that are obvious. So we see the testes, we see the epididymis on top of it, and it has been divided to the head and then tail part. We say the vas deferens or ductus deferens, ductus deferentia, many names that we see being used for that. Spermatid cord would then contain both the ductus deferens or vas deferens and also the muscle pulling up the testes. And then we have the scrotum folded down. Other thing that you could be asked these same structures, but from a model rather than an actual dissection. So we're seeing a lot of similar stuff here. We can start with the testes, see the epididymis on top of that. When we follow the vas deferens, which is not shown on this, we would see that it circles around the urinary bladder. And at the back of the urinary bladder, we had the ampulla. Here we're seeing the prostate gland and prostatic urethra, and followed by then our spongy penile urethra. We had contributions from the bulbourethral gland, or sometimes called Copworth's gland, and then we have the glans penis there. I think these would be more common questions that you would see. So similar questions from the two that we went before, but just asking one structure at the time. So for example, here the big thing would be to notice that, okay, we've got a prostate here. So the duct going through it would be prostatic urethra. Similarly, when you do these, I'm not necessarily a big fan of how things are highlighted on these. So you need to play a little bit of detective game to see it from the both pictures. But we would see testes there highlighted. Scrotum around that, we talked about that thermoregulation wise. Membranous urethra after the prostate then. Bulb of penis, I don't think we talked about that, but that's in the textbook when you go through the material. But really, I think that only time that I would be asking for structures like that is when you're doing the practice anatomy or the practical. In the exam. In the exam, there won't be questions of anything that we haven't covered in the class. We talked about corpus spongiosum, and then on the other side, we would have our corpus cavernosum, so the erectile tissues. And final one that I have here highlighted as well. But I think if I remember correctly, and feel free to correct me, it was more about the quizzes that were more challenging. So rather than spending too much time on this, what I'm gonna do, I'm gonna jump to the view where I can share the quizzes, and we're simply gonna work our way through that. I think that's gonna be the easiest way. And just let me see that I'm not showing any student details. So let's start with the male reproductive quiz. And I think there's 50 questions, which is quite a bit. I'll be the first one to admit. But it adds up to 15 points. Remember that as long as you get enough points to get 90% on the course, you've got that A. This first one that we have here is actually more of a developmental anatomy. So early on during the development, we see for the males and females, we start with very similar structures, but where structures travel then once we mature differs. And this is how the gender reassignment surgeries and so on work, that we use this similarity of the structures. So for the males, we have the gland of penis and scrotum. For the female, gland of clitoris, urethral opening and vaginal orifice. And then we have the shared structures from the past. Really, I think that the only way to, we don't focus too much on our classes on the developmental aspects, and only way to really learn those is just simply by going through those diagrams. So don't feel bad. That is part of the learning process if you have it open while you're tackling the quizzes. So in terms of classifying sex organs and characteristics, the two primary sex organs that we talked about were, of course, our testis and ovary, and their function, production of sperm and production of the egg cell. Then we have our secondary sex organs, such as the uterus, where the fertilized egg cell would then go and develop in, allows for the travel of the ovum to the uterus. So our uterine tube delivers sperm to the female copulatory organ, so that would be the penis. So rather than just naming structures, this time we're kind of looking at the functions. We're trying to mix it up a little bit, but really it is those two go together. The secondary sex characteristics were the characteristics that we quickly touched upon in the class as it relates to when you go through the puberty. You are still going to be a male or a female before puberty, but during puberty, when the sex hormones spike, we see the changes in the secondary sex characteristics, such as growth of hair, breast developments in females. Males often have deepening of the voice, and so on. Then we have a bunch of these multiple choice questions where you are presented with a statement that's not fully complete, and then multiple options. So female reproductive development is directly inhibited by Mullerian inhibiting factor. And the thing is that we didn't really get a chance to go into detail of talking about the inhibition of the development. So this section that you see here at the bottom would be actually pulled from your textbook, and I was just looking if I would have the page number, but I don't have it in front of me now. But really, out of all of these, if you look, it is going to be an inhibiting factor, and it is not going to be to do with the testosterone or testes. So just use the logic of elimination of answers. And remember that I think you can try these up to 3 times. So what I would do if I was a student and I would be determined to get that 100%, I would try through it. And if I don't get 100%, I would look, where did I miss? And then take a note. Nothing prevents you even from taking screenshots using your mobile phone and so on. I know some of my students prefer that. The next question was to match sex organs that kind of are similar when we compare male and female development path, because we do develop from the same embryonic structures. So scrotum and labia majora would be a match, and then we would have the glands of penis and clitoris and the testes and ovaries. Again, if you start with the most obvious ones, testes and ovaries, then you at least have just a matter of 50-50 matching. I don't know if it's very teacher-like to tell to approach it that way, but that's how I would. There is a few more questions about the fetal development. Again, what we're seeing here, really, I think that the biggest thing that we want you to take away from that is that the testes end up descending during the development. And of course, if we're talking about testes, your mind goes immediately already to think about, okay, what structures are we not going to be looking at? We're not going to be looking at ovary, for example. And then it's just a matter of kind of applying what you've seen of the models that are adult models and applying them to the embryonic development. Again, we're seeing more stage by stage this process advancing. I think that since we have 50 questions, I don't think there's anything too radical there. So I'm just going to click through these same structures that we've seen before. I would not expect that since you get asked only so many questions that the fetal portion would be a big emphasis. We have talked a little bit about the region between the thighs bordered by the coccus, pubic symphysis, and ischial tuberosities. So perineum was a structure that we kind of talked a little bit in the past, how that lined all of these cavities. So really, I think that that's the only that would go to the pelvic region. Peritoneum is something that we saw at the abdominal region, and we have talked about that. And of course, trigone was to do with the urinary bladder. So again, that kind of a process of elimination. I feel sometimes a little bad when we're studying about anatomy that there is an element of just memorization. But my goal is that we go through these questions, and if nothing else, you can use them to guide you as you tackle the quiz. Erectile column of the penis that passes along the ventral side and encloses the penile urethra. That's our corpus spongiosum. The other option to consider would have been the corpus cavernosum, but now we just use those anatomical language to separate between those. So I think that those would be the only that could be even considered. Interstitial endocrine cells produce testosterone. So again, really just think of the hormone that we need. Since it's the interstitial cells, endocrine cells, it's not gonna be production of the sperm. It's definitely gonna be the sex hormone. Here we have a true and false true-false exercise. So really, the true statements are usually the easier ones to go. So let's have a look what we could see in the false, what would lead us to tell that they're false. So the conversion of testosterone to estrogen causes an increase in muscle mass and appetite. No, we are not now looking of converting testosterone to estrogen. We remember testosterone played important role in the muscle mass during the growth spurt, also relating to things such as an appetite, but we don't convert it as such. Pure testosterone stimulates the beard growth. Again, we would go to those secondary sexual characteristics, and it's not going to be the testosterone immediately. In fact, what we see in a lot of people who have high testosterone level is that they're bald. So it's kind of a reverse of that. Other statements are true statements. And just because I do want to be respectful of your time, I'll just leave them up there as it is. Sequence of events in spermatogenesis. And I know that in the class I gave that handout where I had listed these, but we didn't get a chance to talk about it. So again, it goes to the fact that in the exam, anything that we haven't talked in the class, I will not ask. But in these quizzes, it is possible that you get asked about those. And really the big thing there would be to use your textbook to guide you or use those notes that I gave. So production of the sperm, we go through the cell division, we go 2 cycles of that to produce 4 daughter cells. So I really think that that's the big story there to take away, if any. Penile arteries and descriptions. This goes into a great amount of detail, and to be quite honest, I probably wouldn't ask you for this amount of detail, but since it is in the quiz, I think it's worth that we have a look of those. And really it goes down to, again, that you just have to memorize the name of the structure, name of the artery, and then what it does, where it is. Use your textbook to guide you. We normally tend to just focus on arteries because, as you remember from our earlier chats, veins are much more unpredictable where you end up seeing those. The next one was a little animation that you were going to watch, and after that you had a question. So spermatogenesis occurs. Where does it occur? And if we start looking at the options, we do know that it's going to occur at the testes. So it's definitely not going to be the epididymis. That's where it went to mature and to be stored. Prostate, vas deferens, and seminal vesicle are all contributing either glands or parts of the duct system. So they're not going to be part of the testis either. So the only part that could be a part of the testis is going to be the seminiferous tubules. So again, just use that process of elimination. Would I go to this detail of questions in the exam? Absolutely not. But since it comes up, I just do want to show you. Oh, I don't know if there were more questions on there. No, I think that was the... Oh yes, there were a few more questions. So let's have a look through those. During the spermatogenesis, which of the following cells is the first to become haploid? Secondary spermatocyte. Correct sequence of cells in spermatogenesis: spermatogonium, primary spermatocyte, and secondary spermatocyte. These all are discussed in that video, so I think that this is really our attempt just to make you watch the video. So while you're watching the video, you can still already start answering to the questions. Don't feel like you have to wait to the end. Answering quiz is part of the learning process. I'm not expecting you to know all of these hard. I'm expecting you to just find out the information. So then when we talked about the spermatogenesis, we remember that we have to halve the amount of genetic material in the sex cells. So there's going to be 2 rounds of cell divisions without multiplication of the genetic material before we move on to the second one. Maturation of spermatids. Spermatids differentiate into spermatozoa by a process called spermatogenesis. Well, really, that is a statement that reads, makes sense. True, false statements, I think, are some of the toughest questions because it's easy to sneak in something that's not true. But I really cannot find anything in that statement that would alert me that, oh, this definitely isn't true. Let's have a look of the next question. So there is kind of referring us to that process of meiosis. We didn't talk about that in the class, and I think that it normally gets covered in a great detail during your intro bio classes, but there is a nice revision of that. And the big thing, if we look at the possible chromosome orientations in that cell, if we have 4 pairs of chromosomes, well, then the math leads us to 16. So how many combinations can we make out of that? Really, I think it gets covered in that video and nothing too shocking. Which of the following statements are true regarding biological distinction of male and female? And I think that all of the statements in this one were true. So none of the statements on this were true. I'm trying to read it at the same time. Yeah, so I think that really the theme that we're trying to cover there is described rather well, and I think this is a section actually from your textbook, this little paragraph underneath that. Matching classes of sex organs and characteristics. Remember the primary sex organs. I think I've been repeating it like to no end, that it's our testes and ovaries. Secondary sex organs are all of the other that contribute to the reproduction. So everything else other than the ovaries and testes of what we have discussed. And secondary sex characteristics were the ones that appeared during the puberty. So I think that was a rather nice and straightforward question. It is the sperm that carries the chromosome that determines the sex of the zygote. Remember that female will always contribute the X, and then it's just a matter of sperm whether we get an X or a Y from the sperm. So egg will always have an X, since female genotype was XX, male XY. So it's up to the sperm, which determines then the sex of the offspring. The sex of a child is determined, and then we have check all that apply statements there. I think that again the ones that are correct have been selected there with the arrows. So during the conceptions at fertilization, same term, different term, same meaning by the sperm of the cell, and whether we have X or a Y sex chromosome from the sperm passed to the child. So really the only thing that doesn't play a role in the determination of the sex of the child is going to be the mother, since we always got the X from the mother. Which of the following statements regarding differentiation of male and female external genitalia is correct? Well, it's the urogenital folds that may develop either into labia minora or urethral enclosure. That goes to that whole series of diagrams that we had a look at the very beginning. Which of the following anatomical structures are part of the tract within which sperm travels from the testes to the outside the body? So we're seeing parts that we have already seen before. It is not gonna be, if we're talking about the traveling of the sperm, the vesicles, the glands are not gonna be where the sperm travels. They simply contribute to the secretions. So it's gonna be all the ducts, all the parts of the urethra that will play a role in that. Pathway of sperm from spermatogenesis to ejaculation. So we remember the seminiferous tubules of the testes, retitestis, efferent ductus, epididymis, where it goes, sperm goes now to mature, ductus deferens or vas deferens or ductus deferentia, then through the prostatic urethra, so through the prostate gland, membranous urethra, and then our spongy urethra, glans, penis, and external urethral orifice. I think the hardest part of this question is really the first three ones because we didn't go to this amount of detail in the class. Having a look of the next one, sequential pathway of the sperm cell, and this kind of follows the way how we revise the male reproductive system. So we have the seminiferous tubules of the testes, epididymis, where the sperm went to mature and to be stored when needed, followed by ductus deferens or vas deferens. Then we had the ampulla, which was the widening of the end of the vas deferens. We had our ejaculatory duct, prostatic urethra, membranous urethra, spongy urethra, and external urethral orifice. You might wonder why we ask the same questions in many ways. It is sometimes because sometimes we just pull the questions from the pool, so we want to make sure that those questions come up. Then we're asking about the accessory glands of reproduction, and I think I'm not seeing all of the question here. So wonder if I move this, would I see? Well, I'm not able to move it and show the answers at the same time. So I'm just simply gonna leave it here. The images that we're seeing where we're supposed to match, we're not really getting a visual of those on here. So I'm sorry, that's not the best way to teach it. We have a clinical case next where the semen is low in volume and the sperm cells have difficulty with moving because there isn't enough energy supply to power the sperm. So which of the following glands could be malfunctioning? And that's going to be the first gland. You remember our seminal vesicle, which secreted that fructose-rich secretion once we finished the vas deferens. At that point, we had gone through about 45 centimeters of the journey. So for that reason, that's going to be time to add some energy for the centerpiece of the sperm to have the mitochondria there to produce energy. Matching hormones of puberty, this really goes back to what we did at the endocrine chapter, but adding a little bit more detail. So I think there's not too much new that I can add of those, just simply a matter of memorization of what hormones do during the puberty. Which of the following is a change in the male body during the puberty? And we do see all of the four with the exception of this one here. So increase in testes and scrotum size, hair growth in the armpits, pubic area phase, increased rate of production of the sperm, and increased testosterone levels. So all of those changes, we're not going to be seeing follicle stimulating and luteinizing hormone changing drastically in this case because we're talking of the male. Remember that they were around, but they're not going to play a drastic role. A decrease in production the decrease in reproductive function resulting in decrease in testosterone and inhibin secretion is called male climacteric or andropause. So just like females went through the menopause, now we're finding more and more information that we do find similar decrease in males as well. So I think that that's all that we're trying to achieve with that question. After meiosis in the male primary spermatocyte, the resultant secondary spermatocytes are generally different than the body's somatic cells. The immune system cell is inclined to attack this as a foreign cell. Which of the following contributes to the prevention of autoimmune responses to one's own spermatocytes, and it's going to be the blood-testis barrier. So similarly as we had the blood-brain barrier, which kept the circulation protecting the brain, that stuff cannot pass that easily, we have a similar boundary between the rest of the circulation and the testes. So again, nothing too insightful from that. The following, which of them might result a breakdown of the tight junctions of the nurse cells, and that could be if we have an autoimmune disease, blood-testis barrier, or sperm count is low. So that's when this barrier concept is not working. Then we have a bunch of questions based on a video again. Spermatogonium, it divides by mitosis to produce spermatogonium and primary spermatocyte. The primary spermatocytes divides by the way of meiosis to produce two secondary spermatocytes. So remember, we go through two cycles. We're now looking at the first step, and which of the following is true regarding the fate of the spermatid? It differentiates into a sperm cell, and the primary spermatocytes and the spermatogonia contain each 46 chromosomes. That is true. So spermatids and the secondary spermatocytes then end up containing 23. Remember, we halved that. So the goal of the process for production of the sex cells was to halve the amount of genetic material, but also to introduce that variation. And all of that is discussed in that video that we have there. The prostate contributes a clotting component to the semen, so that the semen sticks inside the female reproductive system after the ejaculation. So prostatic secretions are important for that. If we have to, for example, remove someone's prostate, that can have an effect on the bringing some challenges with getting natural pregnancy. Inability to achieve an erection in response to direct genital stimulation may be due to the damage of the parasympathetic fibers from S2 to S4. Really, this kind of is a good question that it brings us to connect everything we've learned about the nervous system to this system. So it's kind of trying to do that arching a little bit over, but I don't think that there's really much more to that. The next one is mapping the sequence of events in male sexual response. So the erectile tissue first gets flushed with the blood, and sperm moves from the ducts deferens to the ampulla and urethra, followed by the bulbocavernosus muscle contracting and compressing the bulb and root of penis. Then semen is expelled from the urethra, and the internal pudential artery constricts and reduces the blood flow to the penis at the end. We don't want to have overly long erection. That could be problematic as well. So just the sequence of events is. Again, the male sexual response kind of classified now in terms of 4 events. The first, the deep artery dilates and the bulbourethral fluids is secreted by bulbourethral glands. You remember that was in response to the sexual stimulation. Orgasm divided in 2 parts. First, sperm moves through the muscular contractions of vas deferens or ductus deferens to the ampulla, and then prostate begins to secrete the components of the seminal fluid that made it sticky and stick around. The second stage of the orgasm, the internal urethral sphincter contracts and the bulb and root of penis are rhythmically compressed. So again, we're trying to get that semen pumped out as completely as possible. And the resolution, the last stage, is that our internal pupendicular artery constricts and the blood is squeezed from the erectile tissues back. So we don't want that overlasting erection. Again, we jump back to this developmental bio. I'm only realizing now that we really emphasized it on this quiz, which might not have been totally necessary. But we're seeing the similar structures that we have discussed before. Really, I don't think that there's anything too much of other than memorization that we can offer for that. We continue through the same process, looking again now 10 weeks, moving from 8 weeks to 10 weeks. And then we have a video that covers the remaining questions on this quiz. And again, let's have a look through what we can take away from this video. So centromeres divide during the meiosis 1 and meiosis 2. So they were the ones that held the chromatids together at the chromosome. So those kind of middle parts that held that X together. So they split. During anaphase 1, homologous pairs separate. And then I asked you to organize what happens during the meiosis 1. And it was the formation of tetrads, and followed by crossing over, followed by independent assortment and separation of homologous chromosomes. Really just from the text or from that video that we watched. There is a statement that germline cells are haploid but gametes are diploid. This would not be true. So remember, diploid was 23 pairs of chromosomes. Haploid cell has 23 unpaired chromosomes. So that was just kind of referring to back what you've learned. And again, the law of independent assortment, we've discussed about that before. So that statement would not be correct for that reason. I know that that's a huge number of questions. And now that I'm looking at it, I'm feeling a little bit, maybe we need to revisit that for the future semesters. I do think since it adds up to 15 questions or 15 points, I can see why it's been set up in that way. What I was hoping to do next is to do same thing for the female system. If you do have time, if you have any questions about anything we've covered, please do let me know. I know that it is just a lot of material, but I don't want to drag it on. I want to make sure that you get through the material, but I also don't want to bore you. So feel free to jump in at any time if you feel that there's something that I haven't explained. Okay, so I'm gonna jump back and share what I had before on the PowerPoint, because I really think that it's a good way for us to kind of get oriented for what we're going to be talking on the quiz. So let's have a look of the key points of the anatomy of the female reproductive system. And again, it's not going to be necessarily these 10 questions. I think there's 40 that we pull from, but there is some histology. So again, the textbook will be your best guide there. We can start with the things that are obvious. So we see our nucleus and we see nucleolus within there. We see the zona pellicuda, primary oocyte, and stratum granulosum. They form the primary follicle. Granulosa cells and theca folliculi. I don't think there's anything, it is just really anatomy to a certain level, it's just memorization. Now, I have some spot structures, and then I have some where we go through all of the structures. So just by random chance, the first spot structure that came up on this one would be the mons pubis. You'll notice that it is easier from the models than sometimes from the actual dissections, but I think it's so important that we get some of the dissections for you to look at. Here we have an actual dissected cavator, and there's a lot going on. And when I was doing these arrows, I was thinking, is this the best way to show everything? But let's work together and try to make sense out of those. those. So we're going to start by looking at the three parts of the uterus. So you remember the roof of the uterus was our fundus, major part was body, and the cervix was the little part that partially extended outside from the uterus. We do have our uterine cavity and then our cervical canal and external orifice there. I don't think there's anything too much of other groundbreaking on that diagram. Really, the big thing comes of orienting yourself on these pictures. Sometimes they're pointing to the left, sometimes to the right. Use other structures to orientate yourself. So the anterior side on this would be on the right-hand side, posterior on the left-hand side. I think that the vertebral columns, remaining parts are a great help, same as the digestive tract. Here I have picked a random part, the cervical canal. So you remember the cervix was the most inferior part of the uterus, partially extending to the vagina. I think again, when I look at these models, they are useful for a reason, that things are a little bit clearer there. We're seeing the uterus highlighted completely. Here, I do think that actually the actual dissection highlights it a little bit better, because the highlight color that has been used for the model, it gets kind of blurry. It gets hard to tell what's actually highlighted. We see the mons pubis again. This diagram was the one that I wanted to spend a little bit of time, because this covers everything, or a lot of the things that you might be asked. So we start with the primary sex organ, the ovary, then we had our uterine tube, we had our uterus, and we didn't really talk too much about various ligaments that held the uterus and ovary and uterine tube on their place. But round ligament is the one that we can see here. And then we have these various different parts from the peritoneum that have folded. So where the pouch is, or where sometimes liquid can build up, material from infection. So it might be more of for clinical purposes, collecting samples and so. I think this is probably one picture that's the most common picture that you see when we're studying female reproductive system and the structure of ovary. It is a good picture, but it is a little misleading, because students think that I'm seeing all of this happening all at once. No, you would see only one stage of this cycle at one time. So we're just trying to kind of explain the process, but you would not see everything that we're seeing here at the same time. But let's follow through the process. So everything starts with these primordial follicles. These are all the potential future egg cells that you have. At your birth in the ovary, there's not going to be more. So you are destined to have that many egg cells, and that's it. They start developing through the stages of primary, secondary, and tertiary follicle. Remember, follicle is the developing egg cell and the surrounding structure that maintains the egg cell. Well, once we get to the mature follicle, it then ends up ovulating out the egg cell during the ovulation, and whatever was left behind from the follicle now became this corpus luteum that we discussed, and its important role in the hormone production to sustain the pregnancy. If there's no pregnancy, it simply degenerates and fades away, and the cycle starts again. So I really do think that that's a useful diagram. Just don't let that trick you to think that everything happens at the same time. And I think I just had a couple of last pictures, random structures that the machine picked up from the pool, our clitoris and urethral opening. So I don't think that there's anything too much of those. But what I did want to do was to go through a quiz as we did before. So let me just share that. And I always try to keep these about to an hour. So if I'm going too fast, it's simply that I'm trying to be respectful of your time. But if it's too fast, you let me know. So again, it's going to be 50 questions, adding up to 15 points. And let's go through them as we can. So thinning of cervix during labor, the term that we use to describe that is effacement. I don't think that we even touched upon on the labor. So I really think that that would be just simply from the textbook referring to back, and there is the link to, or the reference to the section where it gets covered at 2805, if you kind of want to follow that. This sequencing the production of the follicle, this is a really good question. And this kind of refers to the diagram that we just had a look earlier on. So you simply are being asked to match the match the statements to match with the pictures. So we had our primary, secondary, and tertiary follicle, ovulation, and corpus luteum. Once you go through over them, you get a little bit more information, but that's simply kind of applying the picture that we saw earlier on. Events that occur before and after ovulation and ovarian cycle. This, again, we didn't get a chance to go to this amount of detail. So using your textbook to drag these to the right places is probably the best way to tackle it. I think the reason why we do this division of the stages before ovulation and after ovulation is that that's the natural spot where we can kind of halve the material. So I really think that the textbook and the section 28.03 is the best. I am not expecting you to be able to do anything else than just answer to this question, but after that you can forget it. I'm not gonna quiz you on this level. And again, I think that we have another similar question referring to the similar region of the textbook, so 28.03. So I don't have too much new to share there. That aligned nicely with the diagram that we completed though at the class. So the next question asks you to organize the structures in the order that they carry an unfertilized egg cell from the production to them being shed out from the body. So it's kind of a review of the female reproductive tract. So let's go through that. Everything started from an ovary, the site where the egg cell was produced. And now we get to the tube system, effundibulum, where those finger-like projections that caught the egg once it had been shed, to the pelvis, pelvic cavity, ampulla, the longest part of the tube. That was the side that was thinner and kind of a more, I want to, for lack of a better word, wiggly. And that's where the fertilization normally occurs. Isthmus is the final part of our uterine tube, short about 2 centimeters, 2.5 centimeters, thicker wall. We've seen the word isthmus being used before. Remember, that's always when we have a straight part that connects two structures. Then we get to our uterus. So fundus was the roof of the uterus, body, the major part, largest bulk of the uterus, and then we had our cervix. And cervix opened up to the vagina, and then we have the connection to the external parts. So I think that that's a really good revision picture. So then we're asking about the process of parturition, and really this we did not even touch upon. So again, I will come back to this, but referring to the textbook, to the section 28.05. So these are the kind of mixing of the hormonal control and what happens. I really would probably just recommend use your textbook while you're tackling this. Again, it goes to much more detail than what I would expect. the ovarian cycle, which was quite an important one, and we spent some time talking about that. This question asks you to put the events in order. So everything starts with the follicular phase. Then follicle stimulating hormone drives the maturation of the follicles, which then estradiol increases the dominant follicle sensitivity. So one of the follicles gets picked, and it's the estradiol that then makes that responsive for further signals. As follicle stimulating hormone secretion diminishes and non-dominant follicles degenerate. So only one follicle will continue to develop further, and we get the surge in luteinizing hormone, and that causes the stimulates the primary oocyte in the dominant follicle to complete the meiosis 1, followed by the secondary oocyte. Now the dominant follicle ruptures, so ovulation takes place, and the follicle, the remaining part of what was where the egg cell developed, that collapses and becomes corpus luteum. So the stages that we saw quite nicely in the earlier review. Uterine changes through the menstrual cycle. So again, that handout that I gave out is super useful for that. So menstrual fluid in the uterus accumulates and is discharged. So we're seeing the consequences of the previous cycle having ended. The endometrium begins to thicken due to the rapid cell division. So we wanted to prepare the uterus for the new cells. So first thickening of uterine wall lining, and then after that, making it vascular and glandular. Final stage that we have is the degeneration of the corpus luteum, and the lack of progesterone as a result of that causes then us to get ready for this shedding, which took us to the first stage. So it really is a cyclical series of events. This is kind of a good question for contrasting males and females in their sexual response. So I think the big take-home message there is that we share certain stages, but of course, for males, it is the orgasm that sheds the sex cells, whereas within the female, you don't have to orgasm for the egg cell to be shed. There's also for males a period of time that is needed for recovery after orgasm. But we do see ejaculation on both, we see erectile tissue, and so on. In terms of the next question, the process of giving birth was one of the 3 times in life when we saw an example of positive feedback. It normally was all about negative feedback, but giving birth, blood clotting, and lactation were the times when we saw positive feedback in the body. Breast development during pregnancy. The development of breasts during pregnancy is due to the growth and extensive branching of mammary glands and ducts. So we're preparing when the baby then is born, that we have resources to feed it. Colostrum and breast milk. So you remember colostrum was the first milk that was shed. We didn't really get to talk about this. I think it is on that handout that I gave out, that I prepared when I have a little longer classes. In the past, I had 3 hours per class, so we had time to go into greater detail. But what you see that the first milk really contains high amount of immunoglobulins, high amount of protein, calcium, and things like that. We really want to give the best boost for the newborn to make it. And as then time passes, the fat content and lactose content in the breast milk increases. Difference between colostrum and human breast milk compared to the human breast milk, colostrum contains more immunoglobulins. So we remember the newborn baby has not now seen all of these potential pathogens that can threaten its well-being, and it's no longer receiving the antibodies from mother's circulation. So we want to pass as much immunoglobulins as possible to the baby, and we do that through the breast. So that's one of the reasons why breastfeeding is beneficial. Best breastfeeding can decrease the incidence of jaundice. So another beneficial aspect of breastfeeding. But again, we don't want to shame anyone. There are medical reasons that not everyone can breastfeed. Then I have hormones and their effects to the female reproductive system. And we have talked earlier on about luteinizing hormone, follicle stimulating hormone. Luteinizing hormones is triggering the ovulation, follicle stimulating hormone, promoting the development of the follicle. We also talked about estrogen and progesterone and their effects on a menstrual cycle, but also in larger scale estrogen feminizing effects with the puberty, and progesterone especially, how it was important for the uterus being ready for receiving the fertilized egg cell. We have not spent so much time talking about inhibin. Inhibin does suppress the effects or suppress the follicle stimulating hormone secretion. So if we have a lot of inhibin, we do not see that being secreted as great amounts. And everything started with the gonadotropin releasing hormone from the anterior pituitary gland. So that's where the luteinizing hormone and follicle stimulating hormone came from. Again, I'm referring to that handout that I gave in the class, which gives a really good summary of all of those. And then we had the childbirth. Again, we didn't get a chance to talk about that, but notice how really, if you look at these statements, there's only one logical order. First, the sac needs to rupture. Baby comes out normally head first. If not, that might be a little more challenging labor. And finally, we want to get rid of the placenta and afterbirth. Having a look of the female sexual response, and again, it's just a matter of matching these stages with the statements that we have there. So again, I think that your textbook does a great job, section 28.04, to describe that. Female sexual cycle, menstrual cycle, you'll notice it's very similar to the diagram that I provided for you. So I've tweaked mine over the years and redrawn this few times, but we're seeing all of this, the menstrual phase where the uterine wall lining is shed, and that was preceded with a premenstrual phase. So the very end of the monthly cycle. So the monthly cycle really starts with dealing with the effects of the previous cycle, clearing the uterine wall lining so we're ready for a new cycle. Proliferative phase referred to the wall of the uterus thickening through the process of cell division. And secretory phase, that's when we saw the vascular and glandular appearance of the uterine wall. Hormones, estradiol and progesterone, I think that the big thing to remember there is estradiol stimulated mitosis, and the progesterone was then the one that was secreted by this corpus luteum that we saw there. Nothing too much new in there. Having a look of matching the regions of the uterus with their description. So the fundus was the roof or the top of the uterus, the most superior part. The cervix was the most inferior part. In between we had body, the main bulk of the uterus. Let's have a look of next question where we are matching each stage of the production of the follicle with the descriptions. So we start with the secondary oocyte surrounded by 2 or more layers of granulosa cells. That was on our PowerPoint. We just saw a little example of that. And then primary oocyte surrounded by a layer of latent epithelial cells. We go next to the follicle containing a single layer of fluid-filled cavity called antrum. And then that was followed by the secondary oocyte surrounded by single layer of cuboidal cells. And final one was the follicle that undergoes through the ovulation. So start with the obvious ones. Probably the last one is easy to match. So our mature follicle there, and then we go through the primary, secondary, and tertiary follicles. Really probably the easiest way to tackle. Phases of menstrual cycle, menstrual phase, proliferative phase, secretory phase, and premenstrual phase. Kind of referring to that diagram that we saw earlier on. And I think we did it in a visual format. We're looking for the term corpus luteum that refers to the progesterone secreting structure that develops during the follicle following ovulation. So the remains of what was the follicle where the egg cell produced or egg cell matured. And this is a really nice graph. And normally I would go into this in a little bit more detail, but just simply because of the time, we didn't really get a chance to go into that. What we're seeing on this graph, when we're looking between weeks 7 to 17, we see the corpus luteum degenerating after the menstrual period. So that's why the hormone levels and so on decrease. What we're seeing here, we're seeing childbirth, and we're being asked what stage, and that would be the expulsion. The baby's head is coming out. Next, we have differentiating the male and female reproductive anatomy. Well, I think that ovaries and testes should be obvious. So for the male testes, female, the ovaries. On the male only, we will see the prostate, ductus deferens, and semiferous tubules, whereas on the female only, we'll see the cervix, vestibular glands, and hymen. On both, we do have urethra and prepuce. So it's kind of a nice question connecting 2 different chapters together. The following statements that are true regarding functional anatomy of the ovary. Ovaries produce the gametes and progesterone. Each ovum is found within a follicle, and each ovary is held in place by suspensory and ovarian ligaments. Those are the statements that are correct. If there was an obstruction in the right common iliac artery, which of the following structures would lose a significant amount of blood supply? Well, it would be the ipsilateral vaginal wall and uterine wall. Again, I really think that you would have to go to the textbook and to the section 28.1 to get that detail. We didn't get a chance to go into it in the class. Which of the following are present in puberty in the females? The onset of the breast development, appearance of the armpit hair, and menarche starts. So the changes that we see as we reach the puberty. Female climacteric, the follicles that remain in the ovaries begin to secrete less estrogen and progesterone, causing the physical changes in the reproductive organs, and follicle stimulating hormone and luteinizing hormone begin to have less effect on ovarian follicles. This change might be something that is too drastic, so we might try to smoothen that out as well, depending on an individual. The symptoms of female climacteric are largely in part of the ovarian follicles' decreased response to gonadotropins, and taking what the following hormones, of which of the following hormones orally may diminish the symptoms of that? Well, we want to replace what's now lacking, the estrogen and progesterone. If we're replacing those, we're not going to see as drastic changes. the menopause, if the woman has gone a year or more without having a period, that's the clinical criteria for the menopause. And we're asking to then differentiate between the menopause and climacteric. So I think that really for the menopause, the big thing there is that we don't have menstruation for a year or longer. And then all of these others are kind of falling to the other group. Which of the following statements are true regarding male and female sexual responses? Unlike the male-female sexual response does not include refractory period, so female can have multiple orgasms followed by one after another. On males, there is a requirement for recovery time. Vasocongestion is a component of both male and female. Female has an orgasmic platform where the male does not, and both male and female have the capacity for ejaculation. Which of the following is a true statement regarding women's bodily adaptations to the pregnancy? All of the statements that are provided are correct. So reduced intestinal motility causes constipation. There's just the space runs out. Mother's blood volume can increase as much as 30%. The tidal volume and minute ventilation increase to meet the oxygen demand. So again, there is a greater need. You're carrying 2 lives. And when salt retention increases, so does the glomerular filtration rate, increasing the urine production. So increased need to urinate, and dermal tears from extensive cutaneous stretching and striding. During the perineum, uterus undergoes autolysis and involution. That really is something that we have not even touched upon at all. I would refer to the textbook section 28.05 to have a look of that. The following endocrine glands or organs that contribute to the development of mammary glands during pregnancy is going to be the anterior pituitary, pancreas, adrenal gland, and ovaries. Thymus has nothing to do with that. So again, it's really just identify what makes no sense, and everything else is then going to be correct. Which of the following hormones help to promote the milk synthesis? The prolactin is the one that I normally discuss in the class. If you look at the handout, I discussed that quite a bit. There are also the insulin and parathyroid hormone, but again, textbook would be the best to give you the full story. What I'm asking is to organize these statements in a chronological order of the events. So milk is continually secreted to into the mammary achene. The infant suckling of the nipple, then the receptors there and on the areola area stimulates those sensory receptors, and these nerve impulses travel to the hypothalamus. And it is within the hypothalamus then where the posterior pituitary releases oxytocin. And oxytocin then stimulates these mammary glands to contract, and milk is squeezed out. So it really is just a matter of trying to make sense. Start from the beginning, finish with the end, and fill in the gaps. I think the handout provides a nice description of that. Which of the following statements is true regarding the letdown reflex? So infant typically gets no milk for the first 30 to 60 seconds of suckling. Damage to the posterior pituitary could result in diminished ability to eject milk, and in this process the epithelial cells contract like smooth muscle. On the next one, all of the following statements are true for explaining reasons why breast milk is more nutritionally beneficial than cow's milk. So we do not really need to get as much protein, or the baby does not need as much protein as there is in the cow's milk. Cow's milk also has been shown to be linked with the diaper rash. Human breast milk helps in many manners, such as providing those antibodies, providing beneficial bacteria to the intestines, and so on. So there is a recommendation. We try to recommend breastfeeding whenever possible. but that's not always possible. So what's being asked next is to kind of match the uterine cycle events with the descriptions. And this really is the diagram that we went through earlier on. So I'm not going to go through it again, but if you use that to guide you, you should be just fine tackling that. Then we have hormones, which their effects during the pregnancy. Some of these we have touched upon before, either in endocrine system, but some of them are new ones as well. So use the textbook to guide you. Aldosterone was responsible for the fluid retention, which we see during the pregnancy. Human gonadotropic HCG prevents the degeneration of the corpus luteum. Estrogen stimulated breast, uterus, and genitalia growth. Progesterone suppresses the uterine contractions during pregnancy. And HCS promotes the release of fatty acids from the mother's adipose tissue. So we're releasing as much resources as possible. Functions of the progesterone during pregnancy. Well, 3 functions that are listed here are correct: suppress the uterine contractions, prevents menstruation, and stimulates the development of the mammary achene. What we're seeing here is a kind of a question identifying the menstrual cycle phase. We're seeing secretory phase. On that one, just from the textbook, I really recommend to section 28.03. This diagram that we've seen before, it's just asking a specific part of it, and that was the proliferative phase where the uterine wall lining was growing thicker. Here, this stage, in terms of the hormones, what we're seeing is the follicular phase, the development of the follicle before the ovulation happens. The second phase after the ovulation has happened are going to be called luteal phase, a term that we have not used before, but that's the term that we use for that. The next one is to put the labels in order from most to least numerous. So there's about there's a large number of potential egg cells that can develop at birth, and then at the puberty we have slightly less primordial follicles. Once we get to the mature ova during your reproductive years, it's about 400 mature ova that gets produced. If you divide that one a month, and then with the years, that adds up roughly. Total days in the reference of menstrual cycle is about 28 days long, so not quite a month, but close there. Standard reference day for ovulation is the day 14 of the menstrual cycle. Approximate number of days in the proliferative phase, about 10 there. About 5 days in the menstrual phase, and number of tissue layers in the endometrium, 2 layers there, and 1 polar body released after fertilization. Let's have a look next. You're being asked for pronunciation, and then just type the term endometrium there. So endometrium would be that. I'm not the best when we're doing pronunciations. I'm sorry about that. And same for menopause, menopause. So I know that was a lot of information, and big portion of that is just simply from the textbook and some amount of memorization. Is there anything in particular that you feel that you are confused or that was tough? I just know that it's a lot. I appreciate that. Remember, this is the last chapter. After that, we're just going to complete the exam, and that's us. I really appreciate you joining me today. If you have any questions, I'm here to answer. Otherwise, I'm going to thank you. I'm going to make this recording available for the evening class as well. And I hope you have a really good competition tonight. I can't believe that you joined me. I wouldn't. I would have been so focused on that. But you're going to do amazing. And I really do appreciate you telling that this was the part that kind of you would like to go through. So hopefully this helps you once you work through. Just keep the video running on the background and that'll kind of guide you through it. Excellent. Thank you so much. I appreciate you. Have a good rest of the day, and I'll see you tomorrow for the dissection of the fetal pig. Good luck tonight. Thanks. Bye. And that's going to complete our recording. And we're gonna wrap up here and see you tomorrow. Thanks again for joining.